Hello friends. Today we are going to see the problem which is asked in May 2011 paper of BEE, and the problem say a voltage of 125 volt at 50 hertz is applied across a non-inductive reactance. Okay, so the important thing to remember here is this: the voltage is applied across the non inductive resistance connected in series with capacitance. Okay, and the current is 2.2 amperes. The power loss in the resistance, so the power loss is given in the resistance, that is 96.8 watt, and we need to find R and capacitance C. So before before solving the problem, I want to give you a quick view of this problem, what we really need to find and how we are going to find. The first of all, we should draw a circuit diagram to get a big picture what we are going to do. Okay, so it is said that it has a resistance and it has a capacitance, and that is connected in series. Okay, so the resistance and the capacitance is connected in series, so I will draw resistance over here. This is my resistance and this is my capacitance, which is connected in series, and the whole circuit is provided with a total voltage of, the total voltage is given to me, that is V. Okay, so the V is the total voltage and this is R and this is C. So this is my circuit which is as per the problem. Okay, and I need to find, I I need, what I really need to find, I need to find the resistance and the capacitance, and the different thing is provided to me, like I am giving with a given with a current in a circuit, and the total voltage is also given to us, the current is also given to us, and the important thing, that is power loss, is given to us at resistance. So the power loss is given at resistance. So at resistance, the power loss P loss is given, and that is how much is given, that is 96.8 of power loss at resistance is given to me. Okay, so this is the whole picture of our problem. Okay, so let's proceed to solve the problem. Okay, so this is your circuit diagram, that is current is given and a voltage is given, and this power loss and frequency is given, and I need to find R. So the first thing I can, which I can easily find, that is R from the power loss equation. What is the formula for power of AC circuit? Okay, so the power is given as I square R. Okay, the power is given as I square R. I know the value of power at resistance, so that is 96.8 watt. I know the value of current, that is 2.2 ampere. I can easily find my value for R. So the R is equals to P upon I square. Okay, so the R is equals to P upon I square. By substituting the value, P is 96.8 upon I square. I is 2.2 whole square. So this is my I and this is my power. By solving this, you will get the value of R, that is 20 ohms. 20 ohms. So I got the value of R, that is 20 ohms. So my R equals to 20 ohm. This is the value of R, and it is found by using the formula of power. Okay, so the formula of power is used to find the value of R. Okay, now the next thing I want to find is the capacitance of the circuit. The the capacitance of the circuit. I find the value for R. Now I want to find the capacitance of the circuit. And in AC circuit, uh, the formula to find the capacitance of circuit is given as C equals to 1 upon 2 pi fxc. Okay, so this is the formula to find the capacitance of circuit, and where 2 pi is constant value, f is the frequency, and frequency is given to me, that is 50 hertz. The second and the last thing, that is your xc. This value xc is the capacitive reactance reactance capacitive reactance, which is not given. The value of the capacitive reactance is not given to us. So the first thing, before calculating C, we need to find the value for capacitive reactance. Okay, so the capacitive reactance value can be found by using impedance triangle. And how the impedance triangle look like? Look like this. So this is your impedance triangle. You can easily see, this is my R, resistance of my circuit, and this is my reactance, and this is my resistance of circuit, and combining this two, the resultant impedance of circuit is Z. So I can rewrite this. As you see, this is a right angle triangle. So to find the value of xc, I simply use a Pythagoras theorem. Okay, and from Pythagoras theorem, I can write that r square, that is one side square, plus the other side square, that is xc square, is equals to z square, hypotenuse square. This is hypotenuse square. Okay, so I need to find the value of xc. So I will take this r square to the other side of equals to, and I will get xc square is equals to z square minus r square. Now taking the square root on both the side, I will get xc equals to under root of z square minus r square. Okay, so from this formula I can easily find the value of xc, but there is one problem. The value of r is known to me which I just value of r is known to me, which I just calculated here. The value of r is 20, which we just calculated, but the value of z is unknown to us. So the first thing to find is the value of z. Okay, here the value of z is unknown to us. Okay, so to find the value of z, we just simply use Ohm's law. Okay, we use Ohm's law to find the value of z. And what's Ohm's law said? That the impedance or the resistance, that is z, is equals to voltage upon current. And what is voltage value? Voltage value is given, that you can see the voltage of circuit is 125, and the current in circuit, the voltage is 125 and the current is 2.2 amperes. So by substituting 125 upon 2.2, I can find the impedance, and the value for impedance is, I will write in next page, that is here. The value of impedance z, the value of impedance is equals to 56.818 ohms. So this is my value of for impedance. Okay, which I just calculated. I have the value of resistance, I have the value of impedance. Now it is just the matter to solve the equation which we have here, that is XC equation. This equation we need to put the value of R and Z and we will find XC. So the XC is equals to under root of Z square minus R square. The value of Z is under root of 56.818 square minus R is 20, that is 20 square. So by solving this I will get XC value, that is XC equals to 53 53.1 sorry 53.18. This is the value for XC. Okay, so this is the value of XC. Now to find the capacitance, that is C, to find the capacitance of C, I just need to substitute the value of XC, which is I just found. So the capacitance C sorry the capacitance C is equals to 1 upon 2 pi into frequency value is 50. So 2 pi into 50 into XC value, which I just calculated, that is 53.818. So 53.18, and solving this, putting this in calc C and solving this, I will get the value of C, that is 59.85 microfarads. So this is value of C, that is C is equals to 59.85 microfarads. This is my value for C. So all the value of circuit is found, that is the value of R is found here, and the value of C that we are calculated by doing this simple calculation. Thank you.